Hey guys, this is the Part-Time Economist, and today we're continuing to talk about statistics, but we're specifically talking about some key terms when we think about probability. Now, probability is the likelihood that something is going to happen, but before we get into it, let's talk about some of the background terms. Now, a random experiment is a process where the results cannot be known in advance, right? So this is flipping a coin, this is reaching into a bag and pulling out a certain colored marble, anything where we don't know the result in advance. Now, a sample space is all the possible outcomes that could happen during our experiment. For example, if we're rolling a die one time, there are 6 different sides, right? So our sample space is 1, 2, 3, 4, 5, and 6, right? Any of those outcomes that can happen is the sample space, right? Now, if we were flipping a coin, our sample space would be 2. We could either get heads or tails, right? An event is a subset of outcomes in the sample space. So, remember when we are rolling the die, there's 6 possible results that we could get. That's the total possibilities, the sample space. That's anything that could happen. Now, the event is one subset of that, such as rolling a 5. Now, a compound event is based off 2 different things both happening. So let's say now that we still have our die and we still have our coin, and this time we want to roll a 5 and get a tails. So our sample space is now 12 because there are 6 possible outcomes for rolling the die and there are 2 possible outcomes for flipping the coin. So we could roll a 1 and we could get a heads. We could also roll a 1 and get a tails. We could roll a 2 and get a heads. We could roll a 2 and get a tails. So we see that as we get more and more events, more and more things, that our sample space increases. Now, the key definition of probability is a number that measures the relative likelihood of an event happening. Now, a probability is always between 0 and 1. Inclusive, right? So 0 means that something is absolutely positively impossible, right? So some things to think of as far as terms of impossible. This would be having a square circle or a blue pen that is also red at the same time, right? Things that just simply cannot happen. And then something certain is something that can't not happen, right? So if you are listening to this video, you have the sense of hearing, right? It's absolutely certain. Now, everything else is somewhere in between. And the important thing here is that a probability is not a percentage, right? So the probability of me flipping a heads is 0.5, right? The chances of me flipping a heads are 50%, but the actual probability is always between 0 and 1. It's not a percent. Now, there's 3 types of probabilities, 3 ways that we can estimate outcomes. The first of these is empirical, and it's based on observed evidence, right? So if I have 10 friends and half of them drive red cars, and then, right, the other ones, I don't know what they drive, but half drive red cars, right? I can assume that based on this observed evidence, if I pick a friend at random, they will drive a red car, right? Because I know this observed evidence. Now, classical is known a priori. So when we are flipping a coin, we don't need to know the history behind it. We don't need to know how many coin flips have come up heads and tails in the past 10 events. We know that it has 2 equally likely chances, right? So classical probability is something like rolling the die, flipping the coin. Now, a subjective probability is based on our analysis, our expert opinion of the situation. So let's say that we know that the president has a very low approval rating, the economy is doing bad. Now, there's only 2 outcomes, either he's reelected or he's not reelected, but based on all the evidence, we determine that it's most likely that he's not going to be reelected. So, there's 3 types of probabilities: empirical, which is based on observed evidence; classical, which is based on the number of outcomes, and then subjective, which is based a little bit on judgment, on kind of getting a feel for the situation. Now, another thing we need to talk about is the law of large numbers. And this basically states that as the number of trials increases, right, so the more times we flip a coin, the more times we roll a die, the empirical or observed probability will approach the theoretical limit. So we know that when we flip a coin, and if we were to do an infinite number of times, we would expect that exactly half would be heads, half would become tails, right? But let's say we only flip this 4 times. It's possible that we might get all heads, we might get all tails, or we might get something like this, where we have 3 heads and 1 tails. But as we conduct more and more iterations of the experiment, we should see the heads and tails start to get closer to the theoretical half and half, right? So in the first example we have, it looks like 75% heads, and then in the second example where we flip it 10 times, we have 1, 2, 3, 4. We have 4 heads and 6 tails, right? So we're 40, 60 instead of 75, 25, right? So we're approaching that half and half distribution that we would expect. This has just been a brief overview of some of the basic terms of probability. I hope the video has been useful, and I will see you next time.